Hello, my name is Max Moss. We're part of the UCI Anteater Racing team. We have Nick on chassis suspension, Davin on human interface, Jeff on drivetrain, and Roel on the body leads. We are competing, our car is XB, we're competing in the Baja SAE competition.
Requirements for the competition is a single-seat driver off-road vehicle with a 14.5 foot-pound torque. Engine comes 10 horsepower stock, has to remain stock, and to protect the driver in the case of a rollover, which is common for the competition.
And here we have a list of goals and stages that we want to meet throughout the process. So first stage is design, which is basically modeling all our parts on SolidWorks and making CAD models, and then running finite element analysis tests on those parts to make sure they're structurally sound. And then from there we move into the fabrication stage, where we actually, what we have right now is the chassis, so we're almost completed with the welding for that. And then from there we'll move into designing the suspension and assembling the drivetrain and the body. And then from there we can start running our tests for tuning and adjusting the car to make sure everything works properly, so that we can compete in May in the Oregon competition.
So some of the specifications for our car, a lot of them are outlined pretty rigidly in the rule book, but there's allowed some flexibility. So our ride height is going to be approximately 12.3 inches with 12 inches of suspension travel, and we're having identical A-arms on all four corners. By using A-arms, we get a good amount of camber control throughout the whole suspension travel, and it allows us to use a lot of travel as well. We are trying to use a reverse gear to allow us to reposition, because one of the competitions is a hill climb, and for off-road vehicles, climbing over rocks, that kind of thing, it's really important to be able to get a really good line, and it's hard to do that in the first try. So the reverse gear will allow us to reposition ourselves until we can make it over the climb. So that's one of the important goals. We're using 23-inch outer diameter tires, and our approximate weight, including the chassis, the drivetrain, the suspension, all the accessories, is going to be under 550 pounds. Or sorry, 550 pounds including the driver.
So for our team structure, I'm at our team lead for the whole project, and then we break it down just to our chassis suspension with Nick, drivetrain with Jeff, human interface with Davin as lead, and then Roel for our body team, and they'll each go into a little of what their subgroup entails.
So currently the chassis is built, and welding, the TIG welding needs to be finished. That's a couple more hours on that. And the suspension, we have 2 sets of A-arms completely finished. And then the rest are being fabricated right now. So that should be done by the end of the week. And then we're going to go into hubs and uprights and shocks and start with the assembly within the next few weeks.
Going on to drivetrain now.
For the drivetrain, so the drivetrain basically entails the engine, any kind of a transmission or gearbox, and then the final drive area and rear end going out to the wheels. So our design for the drivetrain, this engine is given to us. It's the 10 horsepower motor that Dad mentioned earlier, and we're going to use a continuously variable transmission bolted right next to that. So what that does is it gives us a wide range of usable power at almost any speed. It should give us great torque at low speed, as well as giving us the ability to top out the car's speed against wind drag. And then right behind that, we're going to have the forward reverse gearbox, which, as I mentioned before, allows us to reposition ourselves to tackle the hill climb. And then our rear end is a non-differential, so it's just a solid rear end with using CV joints to allow us to have independent rear suspension.
Human interface has to do with connecting the driver to the car, so that includes anything from pedals to the restraints of the driver. The critical points of the human interface is determining the seat angle, so the driver is comfortable, and so we can fit a large array of drivers. We also need to determine things such as a steering ratio. so that going over an off-road, you want to have a precise steering, but you don't want to have to crossing your hands to, continue with a large steering travel. In addition, we did make decisions as well. There's an autocross competition, which is a 4-hour race, and it's continuous, so a comfortable seat would be important, and an ergonomic, correct angle so that the driver is well positioned for those 4 hours.
And responsibilities for the body is the firewall that goes between the driver and the engine, and also the belly pan, which covers the bottom of the chassis as well as the side panels and nose cover. So basically just to protect the driver from any external components. It's an off-road vehicle, so there's going to be a lot of debris and rocks and stuff and things flying around, so you definitely want to keep the driver safe from all those things. And right now we're currently moving into our manufacturing stage. We're gathering the materials that we need to start cutting and assembling all that onto the chassis.
So our schedule for the car right now is we want to have the running vehicle just around spring break, and so this will allow us ample time to test and to see if some of our parts will fail. Even after doing an FEA, we may have had them right on the limit, and there may be additional forces that we could not anticipate, and so this gives us time to repair if needed. And so we want to first test on some local dirt area, making sure we need dirt having a locked rear end. It's both rear tires turn at the same rate, and so turning, you need the inside tire to break loose and kind of lose traction, since it has to spin at a lower rate typically, and so we need dirt versus asphalt, since the dirt has a lower coefficient of friction. And after we prove that test, know that the car will run, we want to go to a local motocross track that's about an hour away, most likely Milestone. And so there we can do more tests. They have jumps, they have other places that we can put it through, beat it up a little more. And after that we want to go out to the desert, most likely El Mirage. They have a test facility with logs and concrete boulders, and they have different rocks and curbs so that we can see, because that's some of the obstacles we will face in competition with the rock crawl and with maneuverability. And so most likely, hopefully these can be once a week after and continually testing, but if things break, we will have time in between to do repairs. And for the final competition in May.
So a lot of the specifications for design have to do with the different events during the competition, like acceleration, hill climb, rock crawl, maneuverability, and the endurance race. And the testing will help us a lot to adjust when needed. And the suspension travel, like the 12 inches that we were talking about, is going to be ideal for any of the rock crawling and hill climbing maneuverability. So our initial designs were decided depending upon these sorts of obstacles.
Thank you.